Welcome to the last lesson of Unit 6, which is Chapter 7.4 and 7.5 in the textbook. We'll start off with 7.4, midpoints and medians and triangles. This is an important lesson for you to understand because you will continue applying these concepts in grade 10 math. In this section, you will examine the properties of line segments that divide triangles in various ways. These properties are useful in calculations for designs of buildings and machinery. So there's something called a midpoint, which divides a line segment into two equal segments. Okay, so it's the very center that would have half the line segment on one side and then half the line segment on the other. Okay, and then there's a median, which is a line segment joining a vertex of a triangle to the midpoint of the opposite side. Okay, so here's the midpoint of this line segment. Okay, and so a median connects that midpoint to its opposite vertex. And then the word bisect means dividing into two. Okay, so a midpoint bisects a line segment. The median bisects the triangle into two. A line segment joining the midpoints of two lines of a triangle is parallel to the third side and half as long. So here's a line segment, L. It's parallel to this line segment. It's also half the length. Okay, and line L is connected between the midpoints of the other two sides of the triangle. The height of a triangle formed by joining the midpoints of two sides of a triangle is half the height of the original. This line segment L is created by the midpoints of the two sides of the triangle. This line now bisects the height of the triangle. So this height is the same length as this height. Okay, so remember the height of a triangle is not, has to be 90 degrees to the base. So this is the base of the triangle. So 90 degrees is this line right here. So this is the height. This is the base of a triangle. Okay, there's a 90-degree angle. Okay, so again, this side L, okay, which is a line segment that connects two midpoints of the sides of the triangle, will now bisect the height of the triangle into two. Okay, so that's why you get these triple lines, means that these lines, two lines are the same length. Determine the length of XY. So remember that XY is half the length of BC. Okay, so this length, line segment, is half the length of this line segment. So XY is BC divided by 2. So 12 divided by 2, 6 centimeters. Okay. Next, determine the length of AC. Okay, so AC is double the length of XY. So XY, they tell me, is 10 centimeters. So AC is going to be double that. So AC is 2 times XY, which is 2 times 10, 20 centimeters. Example 2 is about area of the triangle. So the area of triangle ABC is 36 squared centimeters. Calculate the area of ABD. All right, so the area of triangle ABD is half the area of ABC. Okay, so D bisects line segment AC into two. And it's indicated by these two ticks, telling me that AD and DC are the same length, which means that the area of ABD is half the area of the total triangle. So area of triangle ABD is the area of ABC divided by 2. And then remember, area is, the units are squared. And the same thing with BCD. Okay, so BCD, that area is going to be the same area as this triangle, and it's also going to be half the area of the total triangle. So area of triangle BCD is also 18 centimeters squared. All right, so this one, we are going to compare the areas of triangle ADE. So ADE to triangle ABC. Okay, so why don't we find the areas of both triangles? Now remember, area of a triangle is equal to base times height over 2. So triangle, area of triangle ADE. Okay, so is base times height. So the base is 4, and then the height, it's indicated by these 3 ticks that it's the same as this height. So it's 1 centimeter over 2. Okay, so 4 times 1 is just 4. So 4 divided by 2 is 2 centimeters squared. So area of ABC, again, is base times height over 2. Okay, so the base is here, and the height would be this entire blue line. Okay, so now remember BC, this side length is double DE. So that would be 8. And then the height would be, well, from here to here is 1 centimeter, and then from here to here is another 1 centimeter. So the total is 2 centimeters. And these two 2's would cancel out. So 8 centimeters squared. So comparing the two areas, the total triangle ABC is 4 times the upper triangle ADE. So we can say area of triangle ABC is 4 times the area of triangle ADE. So conclusion, a few points here. The medians divide the area of a triangle by 2. So remember, the medians is the line segment that connects the vertex to the opposite midpoint. So that would divide the total area into 2. Okay, so these 2 areas would be equal. Whereas a line segment that joins midpoints, so midpoint D and E, is joined by this line segment here in purple, or line segment DE. That means that it divides the area by 4. So this area of triangle ADE is 1/4 of the entire triangle ABC. In areas that get a lot of snow, cottages often build a triangular shape called an A-frame. This shape helps prevent damage from heavy loads of snow on the roof. Find the width of the floor of the upper room of the cottage. So the width of the floor of the upper room, that's this line right here. So line segment DE. So find line segment DE. Now remember, line segment DE is half the length of line segment BC. And we know that BC is 6 meters. So DE is half the length of BC. So therefore, DE is equal to BC divided by 2, which is 6 over 2, which is 3 meters. Find the height of the upper room. So the lower room, the height is here. The upper room would be here. Now remember, these two heights would be equal. Okay, so the height of the upper room is the same height as the lower room. So DE bisects the height of triangle ABC. Therefore, the height of triangle ADE is also 2.5 meters. Let's move on to 7.5. Now there's not as much writing in this one. It's more just a lot of information to learn. So a mid-segment is a line segment joining the midpoints of a polygon. So we have 3 midpoints here. Okay, and the blue dotted lines are called mid-segments. So joining the midpoints of the sides of a quadrilateral produces a parallelogram that is half the area of the original quadrilateral. So now when we join the midpoints, we create this parallelogram. So this area inside is half the area of the entire quadrilateral. So there's different types of parallelograms. There's obviously a parallelogram. That is a parallelogram. Okay, so it's a quadrilateral in which 2 pairs of opposite sides are parallel. Okay, so this side and this side are parallel, and then these two are parallel. A rhombus is a quadrilateral in which the lengths of all 4 sides are equal. Okay, so all these lengths are equal. A rectangle is a quadrilateral in which 2 pairs of opposite sides are parallel and adjacent sides meet at a 90-degree angle. So these are all 90-degree angles. These 2 sides are equal, and these 2 sides are equal. A square is a quadrilateral in which the length of all 4 sides are equal and adjacent sides meet at a 90-degree angle. Okay, so all 90-degree angles, all sides are equal. A square is also a type of parallelogram, a rectangle, and a rhombus because it actually meets the description of all 3. Okay, so not only is a square considered a quadrilateral, it's also considered a parallelogram, a rectangle, and a rhombus. Diagonals and parallelograms. The diagonals of a parallelogram bisect each other. So diagonals, remember, is one vertex to its opposite. So that's one diagonal. And then here's another diagonal. So when they meet, they actually bisect each other. So now this length and this length are equal, and then this length and this length are equal. Okay. The diagonals of a rhombus and a square intersect at a 90 degree. Okay, so we get this 90-degree angle at a rhombus and a square. Okay, last page. So ABCD is a parallelogram where DE is equal to 4.56 centimeters and AC is equal to 14.18 centimeters. What is the length of BD? Okay, so we know that BD is double the length of DE. Okay, so DE we know is 4.56. So from D to B, it would be double that. So BD is equal to 2DE, which is equal to 2 times 4.56, which is equal to 9.12 centimeters. What is the length of AE? So AE is half the length of AC. Okay, so we're given that AC is 14.18 centimeters. AE would just be half of that. So AE is equal to AC divided by 2, which is equal to 14.18 divided by 2, which is equal to 7.09 centimeters. Okay, so that's it. There's some homework questions below for you to try, and then there were some homework questions above for 7.4 that you can try, and then, of course, completing today's quiz. Message me if you have any questions.